Hello, I welcome you all. The problem reads, as indicated by the derivation, the principle of work and energy is valid for observers in any inertial reference frame. Show that this is so by considering the 10 kg block, which rests on the smooth surface and is subjected to a horizontal force of 6 newtons. If observer A is in a fixed reference frame, X, determine the final speed of the block if it has an initial speed of 5 meters per second and travels 10 meters, both directed to the right and measured from the fixed frame. Compare the results with that obtained by an observer B attached to the x prime axis and moving at a constant velocity of 2 meters per second relative to A. Alright, so this problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So first things, let's draw the free body diagram. We have the weight and we have the normal force. Any friction? No friction. The surface is what? Smooth, therefore no friction. Great. So this is our weight, which is just mg, and this is the normal force. We are going to be using the principle of work and energy. So let's take note that no displacements for W and normal force, hence no work done. Let's get back to our problem. Here we have two reference frames. We have A, which is fixed, and this one is like all the other problems that we are solving. So all the other problems that we are solving, we were assuming that the observer was in the fixed reference frame. Then we have B. B is a reference frame that is in motion, translational motion in a straight line. Okay. And the solutions, we expect the solutions to be different because for A, the velocity of the block with respect to A will remain the same, 5 meters per second. But in the case for B, the velocity of the block with respect to B will change because both are moving. Of course, they are moving not at the same speed, at different speeds in the same direction. So expect the velocity to change. That we are going to compute, that B will be observing, okay? All right. So the velocity is going to change with respect to B. And the distances also, 10 will not remain the way it is because B is moving, right? The block is moving. What do you expect to the distance? The distance will be less than 10 meters. So we will need to take into account all those factors. So let's go to case 1. Here we are dealing with a fixed reference frame at A. Alright. So we are using the concept or the principle of work and energy, kinetic energy, initial kinetic energy plus the total work done from point 1 to point 2 is equal to the final kinetic energy. We are first working or dealing with A, which is the fixed reference frame. So our initial velocity V1, okay, is equal to 5 meters per second. This is 5. Then S1 is equal to 0. V2 is what we are looking for. S2 is equal to 10. And then KE1 will just be equal to, that's half m V1 squared. All the kinetic energies, V1, KE1 and KE2 are all going to be positive because we are squaring the velocity. Okay, so we have 10 kg by 5 squared. And this is 125 joules. Then we have KE2, which is equal to half m V2 squared, and this is equal to half by 10. This we don't know it, so this just becomes 5V2 squared. Okay. Then we have the total work from 1 to 2. So when we have a force in this direction like this, and the force and the displacement in this direction like this is positive work. And when we have a force in this direction and the displacement is in the opposite direction, then the work here is negative. Alright, let's look at what we have. We have a force of 6 kilonewtons, displacement of 10, and they are both in the same direction, so the work is going to be positive. So we have S1 0, S2 10, the force 6, then the S, then this is just 6 by 10, which gives us 60 newtons. Alright, let's sum up everything. We have K1, KE1 125, KE2, the total work. Mind you, we are using this equation. This is what we are using. 125, the total work is 60, then this is equal to 5V squared, like so. Therefore, our V2 squared is just going to be equal to 125 plus 60 divided by 5, and we square both sides. We square both sides like so, and what we find is 125 plus 60 divided by 5, square root of that. We have V2 equal to 6.08 meters per second. Okay, so let's move on to the second step. Let me move this the other side here so that I can make use of this. So we said no displacements for W and N normal force, hence no work done. Okay, so let's find the time. We need the time. Let's say from here we need this information to there, how long it takes. Okay, the time, let's find the time it takes. Time 1 to 2. Let's calculate this time. Right, for the block. So we know that summation of forces in the x is just equal to MAX. Alright, and we do have F there equal to MA, which is just a 6 equal to 10, which is the mass, times AX, and hence our AX is just equal to 0.6. And we are assuming this is constant. Alright, so for us to find the time, we've got a number of options. Again, this time that we are finding here is for the block from, let's say, this point 1 to 2. Okay, so we have a number of options of finding the time. We can find, you already have the velocity. Okay, velocity, and the final velocity. With the velocity, we are able to find, and we have the acceleration. So we know that our v final is equal to v naught plus at, and t itself is just going to be equal to v minus v naught divided by a, and this is equal to 6.08 minus, our initial velocity, our final is 6.08 minus our initial, which is 5, and divided by the acceleration, and therefore t is just going to be equal to 6.08 minus 5 divided by 0.6, and here we get a 1.8 seconds, right? So having found this time, let's now find s prime. Let's find s prime, okay, which is the displacement covered by b. Okay, so using this formula, s is equal to s naught plus v naught t plus half a t squared. So let's come here. Let's create a boundary here and we move to, so we know that here our s is equal to, this is what we are looking for, unknown. S naught is equal to 0. V naught here will be equal to 2. Okay, and then a is equal to 0 because v naught, because v naught equal to 2 is constant. Therefore, s prime will just be equal to v naught is equal to 2 times the time. The time here, we've calculated the time also. Time is equal to 1.8. Therefore, s prime is just going to be equal to v naught times t, which is equal to 2 times 1.8. Therefore, our s prime is equal to 3.6 meters. So this is the distance that will have been covered by b, okay, as the block covers 10 meters, right? So we are saying b will cover a distance of 3.6, okay, by the time this block covers a distance of, this is the block, of 10 meters. Okay, this is what we are saying. Okay, so by the time the block covers 10 meters in 1.8 seconds, B will have covered 3.6. So it simply means B will be here, okay? And the distance that B will be looking at is this distance here, which is 10 minus 3.6. So this is the distance that we are going to consider as the distance or the displacement that the block will have covered is the one that we are going to use in computing work and everything else. All right. So let's go to case 2. We found case 2, and here we are using the translational reference frame, okay, at B. Okay, right. So using the same concept of work and energy, we have K1 plus the summation, the total work done, which is equal to the final kinetic energy. Right, so our V1 here, okay, is going to be the relative velocity of V block with respect to B, and this is just equal to 5 minus 2, and this is equal to 3. S1 is equal to 0. V2 is what we are looking for, and then we have the last part, which is S2 is just going to be equal to 10 minus S prime, and this is equal to 10 minus 3.6, which is equal to 6.4, right? So we have KE1, which is just equal to half mv1 squared. This is equal to, we have a 10 there by v1, and our v1 is 3. This is the relative velocity of the block with respect to B. Right, so this is 5 by 3 squared. So we get a 45 joules, right? And then we have KE2, this is equal to half mv2 squared. This is half 10 by v2 squared, and this is just equal to 5 v2 squared. Then we have the summation of the total work from point 1 to point 2. These are both in the same direction, so we are integrating from 0 to 6.4 of the force 6 ds, which just gives us 6 by 6.4, and this is positive, and this just gives us 6 by 6.4. Okay, 6 by 6.4. This is a 38.4 joules. So summing up everything together, we have a 45. The 45. Then we have 38.4. Then this is equal to 5 v2 squared. So v2 squared, we have 45 plus 38.4 divided by 5, then we square on both sides. Right. Once we do so, then we'll have 45 plus 38.4 divided by 5, and then square root of that. And then we get a V is equal to 4.08. Therefore, V2 is just equal to 4.08 meters per second. Alright, so we are done. We found B2 for the first case, and then we found B2 for the second case. When we compare the two, of course, in the first case it is higher, or in the second case it reduces, and it makes sense because B is also moving. I guess this is about it. We found this solution there, and we found the other solution there. Right, so I hope this is about it, and I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.